with this frequency response here, the top here is the two microphone Behringer ECM 8000s inside the bass cabs, and then going into the audio mixer. So I'm taking the sound frequency sweep simultaneously. The other ones that I did that were independent, left to right, and then try to use the PEQ on the DCX to individually shape the frequency close. I got it pretty near. I could have gotten it even more transparent with a little bit more few hours of trial and error, because every time if you use the Q bandwidth, some part of that also is adding either a subtraction or a multiplying of the frequency. If you turn, say, 0.1 of a dB on the DCX, plus or minus, and then do a sweep with two, that's something that's perfect. That's a direct frequency response, and then you're going to see like the frequency response with the 0.1 looking more like half a dB or something, because the Q adds or subtracts. So it's you got to go over this over and over. So it's a long hour process. The frequency response below is with an offset of minus 38.2 dB, and that's a direct frequency response on the amplifier, measured on one of the amplifiers to the JBL. That's over this side, because I can't connect all the subs up to the THX, because I tried that, and that's plus signal. Pretty bad idea, I think, because then it's noticed the signal increase, but also then started to notice confliction with clipping or distorting sound, and well, that's not a good idea. If I wanted to, I mean theoretically, if to measure multitudes of subs and they're all coming from individual amplifiers, and if I wanted to monitor each one singly, or if I wanted to monitor them all simultaneously, yeah, it's got to be done so it doesn't cause any hiccups. Yeah, and of course there's only one signal that's only going to the sub. It's only one single source. Just raise the level here. I was just thinking about the curvature. I'm pretty sure last time I did a curvature of the direct, yes, it showed very lows. But I'm not sure if I can remember if it started to slope downward, and it's going smooth. And I'm thinking, I know I've done some changes to the sound system recently, but there's only I checked to see if I had any other additional PEQ filters or anything else turned on, or and that sweep up there is with the DCX crossover switched off. So the only frequency crossover on the Denon, and I think it's set at 150 hertz at the moment. You could set it at 250 and then it goes back to 40 hertz. That's 250 is the most it go to, but that's neither here or there, because I did the frequency sweep from the lowest up to about 120, because where there it is, it starts to roll off. Not the LFEs crossover, you know. You could turn that flipping thing off, but the actual signal itself is a filtered frequency response that goes from the very lowest up to 120. They say it used to go a bit higher than that. I think it used to go bit more higher, but I think over the years, since 70 mm to Dolby Digital or to digital sound, I don't know. That could be anything. Could be CDS, you know, cinema digital sound. You know, from there they changed they engineers or whatever, they decided to change the frequency stop point for the sub bass or low frequency effects, baby boom, whatever. Anyway, I'm just curious why it's sloping, but doesn't seem to be any problems. Doesn't seem to be any problems. You know, I've thrown the kitchen sink at it, and it's not a problem. I think it's coming back as a distortion or whatever. Maybe it is. I just can't remember. I would have to look for any past Room EQ Wizard frequency graph that I would have done a direct. I would have done a direct at versus the amplifier. But the amplifier, that's, you know, that's what this curve up here is at the top. I haven't got the THX connected to the sub line itself, so it goes into the processor mode on the THX. I haven't connected that lead. I haven't connected that wire. That's a simple thing. It's just I could do that with crocodile, a little bit of wire, a couple of crocodile clips, and I can then see the processor frequency response, that which is going to be the total opposite of the amplifier one, because the processor is where it's the signal. Well, that's the thing, because it goes through a heck of a B chain here. So it's coming from up here. Well, actually, it's coming from the computer first, through the program on the REM, and then it's coming to here, and then from down here, it's going down to here, and then that's for the sub B chain, and then from there it's oh gosh, is it? I think it's here on the FBQ, and then the outputting and so forth connects up to channel B on this DCX here, and then that's left front sub, and that's the right front sub there, and so they're independent, even though they got the same signal. But then the characteristics of them I got to adjust until I had you know, the so I'll turn the other graphs off. So that's the two here. The that's the right, and that's the left. There's only a slight margin of difference. Needs to be adjusted, and that could be level and a bit of PEQ. And like I say, got to apply what type of curvature on the bandwidth on the Q bandwidth, and then how much, you know, you just take a little bit at a time at 0.1 decimal steps until everything kind of falls into place like a jigsaw puzzle, because it is like sandpapering, and you sandpaper very gently. You got a little bump in a bit of wood or something, you've car body filler or any sanding wall, you know, and you just do a little gentle, you know, just like if it were model making, you just do a little gentle and then check it with your finger. Our fingers are very, very clever to our mind, and then we think, yeah, that feels smooth. Anyway, so if there could be a bit of ongoing here, so I would have to check the realistically I would have to get in the back of the behind there, connect a line, a very long lead. I've got lots of cables here. I've got lots of them. I've got enough audio cables in this home cinema to sink a battleship. Believe me. I could connect that directly to the THX, or I could connect it directly to the computer. I could do the tests connected to the computer, to the THX, to the and then reconnect the lead, and then test the output from here before it goes down to here, and then if that looks okay or whatever, I can then see what's going on and then test and then connect these back up. So I'm only testing, say, this on the output, but not this. So I just swap the XLR lead around and test that part of the B chain, and then reconnect everything up and then test that part of the B chain. So, you know, there could be several things going on, but it's not like I'm missing anything in the even with the sub as it is in the cab. It's not like I'm going to miss a bit of infersonic there. Blimey, it's only sloping very gently down, but the other frequency swipe there up here. Turn that one off. That one done. Wow, that looks very ideal. Especially, look at that. I mean, right down to flipping 10. No, it's not even going 10 hertz. Flipping that, and then it slopes down gently in single digits. Flipping that goes down low. And then it kind of breaks up, sort of thing. Kind of goes a bit weird. And that's probably just noise, or it's just simply the processors or whatever. And there's some sort of restriction down there. Otherwise, theoretically, you should just see a straight line. Everything should just be straight. Because they do have filters in all this equipment. There are low pass filters and so forth, and you know, you could deactivate that filter permanently, or put a toggle switch on it, so you got like a switch that you could turn it on and off. But that's okay. It's too bad it can't be like that on there. But the problem there is if okay, that's the frequency sweep on the one of the subs on the right. That one there. Let's add the left one if I can. No, not all in one. Oh yeah, there we go. If I add any PEQ filters on the FBQ or DCX, turn them all back on and that, and then use anything on here, which I use as the finalizer, it's going to add or subtract on the other frequency, you know. I can only think of putting something like make a DIY low pass filter that could somewhere be between this and then bring it down, lower it down slightly, if you know what I mean. And that would be done passively, while still the signal electronically going in. And I suppose there's all the other things like the teal parameters and the flipping flux capacitor, and oh god knows who bloody cares. And then what other people are going to say, you know, if you're going to experiment. Maybe they don't want to, maybe they can't, maybe their life is being controlled by their nagging wife, and they're just feeling a little bit jealous because someone's got more time on their hands. But yeah, and you know, you got to have special subs, or you just got to have something that's got multitudes, so they only play a specific part of the frequency range, because you don't want to create any harmonic tones or anything, you know, if you're going to play something infersonics, because something will crop up, and then you're going to see it on the the REM. You're going to see these other frequencies in front and think, what's going on there? Those are harmonics. Those you don't want to, because you're going to hear them. If they show up, you're going to hear them, and then you're going to think, oh wow, I'm getting really great infrasonic low bass on that stupid movie starring Tom Cruise with that stupid sound effect on the opening, or that overrated, overplayed Black Hawk Down, Bloody Irene. You're going to see something there that shouldn't be there. So you got to add so many multitudes, so it could be done without overdoing it. But really, you might as well just have a good tug. That's just about as good as infrasonic as it gets.